So welcome everyone to this session on what's new in Spring Data. My name is Christoph Strobl. I work for Pivotal, and there I'm part of the Spring Data team, working mainly on the abstractions for MongoDB, Redis, Solr, a bit of Commons, JPA, and so on. And in the next 30 minutes, we're going to talk about the Loveless release. You might know that Ada Lovelace was best known for her work on programs for the analytical engine created by Charles Babbage. But for us, as the Spring Data team, the Loveless release means almost a year of work, solving over 900 issues across 16 modules. And we had some major themes in this release, which are basically performance. We had a new module that Ollie announced just in the keynote, the JDBC module. We've been working on transactions for MongoDB, and along that route, we've been working on a lot on reactive and also on reactive transactions. Along the lines, there have been enhancements to, let's say, Apache Geode and Gemfire with JCache. We've added a lot of Kotlin extensions across the various modules. We added support for client sessions in MongoDB. We have extended support for scanning the cluster, a Redis cluster. And of course, we added additional support for Vavr types, like we now support the try type as a repository method return type, which is a huge improvement for some of the guys who are huge fans of Vavr these days. Yeah, so let's dive into a selection of the more, at least to us, more important features for everything I show you today. There will approximately everything I show you today, not all, everything, but for most of the stuff I show you today, we already have updated examples in our Spring Data examples repository. You might also want to check out the What's New sections within the documentation of the individual stores to find out what's new in the store you personally care most about. So let's jump right into enhancements to Spring Data Commons. Those are the enhancements that basically go into all of the modules that we have. Some of the features might arrive a little late because they require the module to be touched. But some of those are available throughout all the modules. And one of these features is Immutable Setters. So this is basically, or also known as Vavr methods, if you know Project Lombok. So these are methods to create a copy of your existing object, altering just one particular field, and this is what it looks like. So you imagine you have a value class, and it has those final fields over there, and then you get this Vavr method down there, which says with ID, though the ID is nullable. And it now creates a new value class, just setting this very ID. And with previous release trains, we would have just ignored this Vavr method and all the logic that resides within it. And we'd just go on and use reflection to set the ID field within the property. So now we're respecting those Vavr fields, and all your final fields within your classes. And we understand final fields as such as those that don't have an explicit setter method and that are not part of the constructor. So we respect those when reading entities from your store, and we'll go on and invoke those Vavr methods. But this comes at the price. So this additional enhancement that makes us more aware of of your domain. And imagine you have this ID string over here. It's obviously not final, but it doesn't have a setter, and it's not within the constructor argument. So right now what would happen is once we detect such an entity, previously we would go on and just set the ID field via reflection, which we now don't do anymore. So this can probably, if you upgrade, lead to issues. And you might end up looking like this a bit, so that's why I'm pointing it out here. So if you have such domain types, please make sure to either have the ID value set within the constructor, or at least to provide a setter for it. I know that this is a common problem. Sometimes if you're using JPA repositories and you had your ID and it was set by a Hibernate or whatever JPA provider you were using, then you were used to, this just works out of the box. So with the Vavr release, we changed this because of this, with the method support and respect to the domain types and setters and the final fields that you have. So please, when you do so, be aware when you upgrade. All right. On another route, as I mentioned before, we've been working on performance quite a bit, and especially on the application startup performance. So this has not only been an ongoing effort within the core framework, but also within the individual modules. And the same is true for the Spring Data modules, because as you can imagine, once you have, let's say, a larger domain, then there is a bunch of classes to inspect, a number of repositories to initiate at startup time. And of course, all this scanning, this metadata creation and instantiation of the repositories itself, it took time. And in some cases, it took a lot of time. So we have an example up there where we tried to instantiate 2,000 domain types, repositories, and whatnot, all along the lines. So what we did, we added some improvements there to just reduce the startup time of your application. And as you can see, we introduced, this is the default mode, what you've been used to, and we introduced two more modes. One is the deferred mode, and the other one is a lazy mode. And what this means, I can show you on JPA, because this is one of the first modules that already implement those bootstrap strategies for repositories. And for JPA, using, as mentioned before, those 2,000 domain types and repositories, we had a startup on one of our machines that took about 35 seconds for the whole application to start up. Now we got the deferred bootstrap mode, which basically goes on and pushes the repository initialization into a background thread so that the application is able to start up while already initializing the repositories. And we were able to reduce the startup time of your application by about 10 seconds or so on our test machine. If you want to check it out, there is the Spring Data examples repository. If you don't know it already, there is a dedicated example, so you can run it on your own machine to see what it means for your scenario, this bootstrap mode. Of course, to be able to push the initialization into a background thread, you have to add an additional bean. And yeah, this looks a bit clumsy, because you need a thread pool task executor and all the JPA stuff and whatnot, and then set it up this way. You can find it in the example. That's the way to enable it, unless you're using Spring Boot. In the current milestone M4, there is an additional property that you can set. So you just go on and use Spring Data JPA repositories, bootstrap mode, add the mode that you want to have, and they will add the local container entity manager factory bean. Yes, sir. To your application context and just do it for you. And of course, we got the lazy mode, which means that we don't start up repositories in parallel, but rather wait for the first usage of a repository. So this is, if you have repositories that you might not even touch because they're there and unused, then those won't get initialized at all, and so you can save a bunch of time. Though, of course, on first access to your repository, all the bootstrapping starts, and the first request might take a little longer. All right, moving on from JPA to the new module JDBC. So this has been worked on for now over a year. It strives to make data access really, really simple and grounded, let's phrase it that way. So it leaves out basically all the stuff you potentially might not need the JPA adds like second level caching and all that stuff, and really tries to go straight to the JPA syntax. And it pretty much looks like any other Spring Data module, you know. So there's the CRUD repository here. We got queries. We even got the add query annotation, so you can add your custom select. We got modifying queries that allow you to just customize and modify whatever you have within your database. Jens is giving a talk today at 2, going into the very details of the JDBC module, what it can do, what the reasons behind all of this is, how to work with, let's say, DDD aggregate roots, and how those come into play when it comes to relations between entities. So if you want to know more, make sure to check out Jens' session. I guess he'll also show the integration that the Spring Data JDBC module has with Juke and MyBedis. So there is already integration there. And so just you get a feeling what it looks like. So this is one of the examples that we have. It's basically the CRUD repository, and we saw before the query and whatnot. We have it's a boot application, so there's already infrastructure for it. So you can have this auto-configure JDBC module, or boot will already detect that there is the JDBC module on your class path and bootstrap everything for you. There's even a JDBC test annotation from boot already, and you can just go on and then create your, in this case, Lego set. And with the set, you can build different models, and you have a manual over there. And just to prove that all of this really works, let's just quickly run this very test. Come on, start up. Thank you very much. So you see, this is just Spring Boot. It just inserts the Lego set and then loads, tries to find all, and yeah, even updates some with the custom queries done here. You could also run this one to just see how the update is executed, and then load it again via the JDBC module. All right. Of course, along the lines of JPA and JDBC, there is always the question, yes, this is all synchronous, and Ollie already mentioned it today in the keynote. There is this new module or approach that we are currently experimenting with, the R2DBC, and this is an outlook I want to give you on this particular project. I really encourage you to have a look at R2DBC and our efforts around it. Play around with it, and please share your feedback with us. We really depend on it to see if the direction we are heading is what you folks need. So please check it out. As you might have seen already in the keynote, what we have here is we have a reactive database client that has currently, because we lack a better concept, a sort of transaction closure in a reactive way. So within that closure, you can operate within a transaction reactively. And this is basically what it looks like. So you have this mono, you get this DB object, and you can then, with the Fluent API, say insert into a certain domain, a given entity, and then maybe later on add some SQL to just delete this very entity. Right after this session, Ben Hale, who's sitting right there, is going into the details of reactive relational database connectivity. So make sure to just stay in this room and learn more about your reactive database client and our efforts around it. I currently have on my local laptop a Postgres SQL running. And what we have here in our Spring Data examples, there is a dedicated R2DBC example. And you can see here that we have this reactive CRUD repository that Ollie showed today in the keynote, along with a query, a custom query. And we got our infrastructure configuration. So what we have here is the reactive database client and the Postgres connection factory to just spin up R2DBC repositories. This is currently work in progress. as you can imagine, so this is not the way you're familiar with when using Spring Data repositories, like having all this auto configuration there, but you have to set it up that way for now. But as said, we're working on it. And then you can go on and really define your queries. So here's the annotated query. So we're adding some customers into the database, into the Postgres database, and then call this reactive customer repository in a reactive way. We use a reactor step verifier to just make sure the test passes and does the right thing. So let me quickly run this. So it connects to the Postgres using the reactive driver and the reactive database client. And as you can see, the test passes. So this is not slideware, but this is really an active project that already shows results and is working. There's been a question?
Yeah, quick question about the CRUD repository and the reactive CRUD repository. You said they integrate with Juke and MyBase. In the examples that you're using, how does it mapping the response, the SQL response, like the columns to the object? Is it just assuming that they're the same as the field names?
The question was how the field mapping for JDBC repositories work, and that's a pretty good question. And I urge you to talk to Jens or go to his talk later today, because he can tell you a lot about the field mapping that happens in there and how to apply different mappings using MyBase and Juke, of course. There's another question. Yes, please. I can try, sure, making the font a little bigger. Let me just, there you go. Font. Let's try with 20. Is that better? All right, you're welcome.
In your example that you show where it creates the ID for you, you mentioned that that might cause a problem with GPA, but is there a way to turn it off when you're using GPA?
The question was if the with the methods and the JPA IDs, no, it's not. You can't turn it off because it's embedded within our library. It isn't a JPA issue at first or a Hibernate issue, but rather how we instantiate entities for you with our property setters and stuff. So this is just how we respect domain types and the visibility of properties in there, because you obviously shouldn't set the final field or whatever via reflection. That's just something you shouldn't do in this case. All right, so let's move on to a store where Reactive has been around for quite a while. I have to hurry up a bit. And this is MongoDB. So with MongoDB 4.0 being out, we have added support for multi-document transactions. So previously it's been single. Updates to single documents have been atomic all the way. With MongoDB 4.0, you're able to leverage all the Spring managed transaction support, which means you can add a dedicated Mongo transaction manager to your application context, and then you can either go on and use the transaction template to operate within a transaction spanning multiple collections and updates and insert statements. Or you just use the declarative transaction support with enable transaction management and transactional. There'll be a dedicated session today at 3 p.m. that I'll be giving together with Jeff, who's sitting right there from MongoDB, where we go into the details of the transaction support and how to use it and what it means for your application. Along the lines for MongoDB, we also added validation and JSON schema support. Validation with a query has been around for quite a while. So in MongoDB, you were able to define, let's say, this query that would match a certain number of documents, and each and every document that you inserted into the store would have been matched against this very query and rejected if it didn't match. Because as you know, MongoDB is a truly schema-less store, but you could enforce some sort of validation onto it if you wanted to. So we've been adding support for this kind of validation with our very own criteria API with this release. So you can, as you would define a query, you can create a validator out of the query and then just pass it on when creating the collection to just enforce this. And also MongoDB 3.6 added support for JSON schema, which is another way of validating your data. So it doesn't use a query, but rather a more object-oriented approach as you would imagine. So there is an object type, it has required properties, and it has properties that have certain types that can have constraints. So it's more an object-oriented approach. And for that reason, we created something called a MongoJSon schema along with a Fluent Builder API, so that you can define your schema upfront using a nice Java API defining like properties like string name and the minimum length and whatnot. We also added support for distinct queries in MongoDB. And when it comes to distinct queries, many of us coming from a SQL world think about this, which is not quite the case for MongoDB, so forget about that. It's more like when you query a collection in MongoDB and you query for the sizes distinctively, then you get, you see, this is size M, and in this case, we got an array of sizes, so this has small and large, maybe as properties in there. Then what you get would be a list of those distinct sizes instead of having, let's say, size M and then an array of, but it just flattens out arrays for you. So what you can do, you can use our Fluent Query API, Fluent Template API here to query for distinct values, just like you would expect to. It's just say distinct, tell it the property, give it a type if you know it. So this is obviously strings. So OK, those should be mapped to strings. But as I mentioned before, MongoDB is truly schemaless. So you could have a size defined like this, length 8. Then obviously it wouldn't map to a string. So I would advise you to just retrieve objects and leave out our mapping layer in there. And we added support for change streams. Those of you using MongoDB might have done this in the past, like tailing the op log. There is a new API that pretty much does the very same stuff, just untangling op log entries that happen during a transaction. So if you do this and operate within a transaction, it will look a little bit weird. Using the change stream API, you get those untangled. And we added change stream support for both asynchronous and reactive API. It feels more natural using the reactive counterpart, because then you just go on and say, like, OK, I want to filter on a status and have some change stream options. And then I go on to the reactive template and call change stream a certain collection with the options and map it into a user type. And it returns a flux of those change stream events. So you would get notified whenever a matching document is inserted or updated within your collection. For the synchronous counterpart, we introduced something new into Spring Data MongoDB, and this is the default message listener container, because obviously subscribing to such a change stream would be a blocking operation, so you would subscribe and then you would end there. So we deferred this to a message listener container operating upon a bunch of threads. So you register a callback in there, which is like, yeah, you give it a message listener that gets notified whenever there is a new message. And then you can go on and just register the change stream request within the container. And having those message listener containers in place enabled us to not only support change streams, but also to support tailable cursors on capped collections. This has been only possible for when using the reactive API. Now you can also subscribe. You can also use tailable cursors via the synchronous API using this message listener container concept. I got a few more minutes left for Gemfire. It's been a lot of work, mainly around the boot integration and health indicators. So you can now check your Gemfire cluster state for caches, disks, regions, pools, and whatnot, many more. John put a lot of effort into those. He also added the Spring Session integration for Apache Geode and Gemfire. Unfortunately, his session has already been yesterday, so make sure to watch the replay on scaling boot applications with Gemfire and Geode. On the Redis side of things, we added query by example support via the query by example executor. This one is available for other store implementations as well, so if you don't know, just add it to JPA and you can use query by example on JPA. And the way it works is just you create basically the sample with all the properties you want to match, and then you call repository find all on Redis repositories, and it will go there and fetch everything for you. We also got support for write to master or primary and read from replica or slave. Salvatore just renamed those from master slave to primary replica. So this is why the drivers haven't catch this so far, but there is still slave preferred. This will be someday replica preferred. But you can now use Spring Data Redis and make sure that you write to the master and read from the replica. We also got Reactive Pub sub. If you're using that one, feels pretty straightforward. So you got, again, some message listener container, because you could share if you want to use a shared connection. So you could basically go there, set up the container, use one connection, and just retrieve everything, or you shortcut it and use the template and listen to channel. But yeah, this opens up one connection for each and every subscription, whereas the container just uses one connection. So if you're eager with your resources, then just use the option below. Reactive cluster scan, I mentioned this one before. This is more a tricky part because there's been the keys command has been around. It's a blocking command, that's why it's returning a list. Other than that, there is the scan command that pretty much does a keys-based scanning, such as the keys command, but in a non-blocking way, so it won't block your connection, nor will it block the server. And the tricky part is, if you have a Redis cluster, you have to go to each and every cluster node and execute the scan command there, and then aggregate all those responses into a single flux. So this is what we added in there. If you want to know more, make sure to check out Mark's session. He's going to deep dive into what we did there and what it means to have a reactive driver. For Cassandra, it's been Lifecycle Events. So we publish those now. And of course, we added a Fluid template API. So you can really now go on there, say template query matching, give it the query, and then call all or whatever, instead of having this very one method like query and then give it 5 parameters or so to do what you want. And we added, of course, the Kotlin extensions for those so that it feels really idiomatic when you're using Kotlin and you want to use any of our Spring Data templates or repositories. This is not only available for Cassandra, but also for the other modules. All right, last but not least, Neo4j. They've done a lot of housekeeping in aligning their naming to other Spring Data components. They added spell support for queries. They added optimistic logging, which they hadn't before. They have now support for persistence constructors. So previously, you had to have a default constructor within each and every domain type. Now you can have persistence constructors, and they allow you to traverse Neo4j relationships in derived queries. With that, the Loveless release is out now. It's been released last Friday. Check it out. It comes with the Spring Boot 2.1 M4 release. And if you want to hang out with me and Jens Schauder today and like to work out with us or just see us sweat, make sure to be in the fitness center at Level P today at 6 p.m. And thanks for your attention.